Mr. Heffron here, and here's a video on weather and climate. Okay, so climate is your long-term average weather conditions that you should expect probably may happen. However, weather is the actual conditions you're experiencing, and they can vary greatly. Okay, so people often get weather and climate mixed up. Weather is the current conditions, whereas climate is the average conditions over a long period of time. So down here in this little graphic here, weather is the short-term state of the atmosphere. It can vary from time to time or location to location, and it always includes time and location. Climate is your long-term pattern of weather, long-term as in 30 years or more of data, and the average weather over many years in a specific place. So just taking a look at weather now in specific, you can have a nice sunny day like this in Toronto, and then an hour later it can look like this. It can be cloudy and rainy. Conditions can change within just a couple of hours. Things you are interested in weather are the temperature, wind speed, precipitation, which is like rain or snow, the type and amount, the relative humidity, atmospheric pressure, the presence of fog, mist, or cloud cover, visibility conditions. And for example, today may be partially cloudy with scattered rainstorms with a high of 15 degrees and a low of 5. But weather can vary by the hour, and it can be forecast only accurately by a few days. So let's take a look at temperature first. Temperature is how hot, warm, cool, or cold the air is. It's measured with a thermometer. And most of the world uses Celsius, or some people call it centigrade, degrees Celsius. The US uses Fahrenheit, and scientists, we use Kelvin. Kelvin is, if you reach 0 Kelvin, you have no energy. Okay, so if you take a look at this little scale down here, Celsius is based on water. 0 degrees is the freezing or melting point, and 100 degrees is the boiling point or evaporation condensation point. And when they discovered the coldest possible temperature in the universe was minus 273 degrees Celsius, they decided to move the scale over and call it Kelvin. So 0 Kelvin, which is known as absolute zero, is minus 273 Celsius. And when you hit, and then after that it's the same as Celsius, the same interval rate. Now, Fahrenheit, for some reason, is based on a brine solution instead of water. It has a freezing point of 32 degrees Fahrenheit, and the 0 has something to do with the brine solution. And it boils at 212 degrees. So there's a 180 degree difference between freezing and boiling, where in Celsius it's only 100 degrees. And just out of pure luck, minus 40 Fahrenheit is minus 40 Celsius. Just works out to be the same. So the formulas for doing conversions are pretty simple. If you want to know Fahrenheit and you know the Celsius, it's 1.8 times the Celsius plus 32, because at 0 Celsius is 32 Fahrenheit, and when you go up 180 Fahrenheit, that's only 100 in Celsius. If you want to go between Kelvin and Celsius, the Kelvin is the Celsius plus you add 273. All right, here's an example. Let's say you're a NASA astronaut and you want to know what the temperature is in Kelvin if it's 100 degrees Fahrenheit. So 100 degrees Fahrenheit, you usually don't go outside in those conditions. So here we have Fahrenheit is 1.8 times the Celsius plus 32. You rearrange that by subtracting the 32 and dividing the 1.8. And so 100 subtract 32 divided by 1.8 is 37.8. Then if you want to convert that to Kelvin, 37.8 plus 273 is 311. So it would be 300 degrees Kelvin. Example 2. Let's say you're where the world temperature record is in Furnace Creek Ranch, California, in Death Valley. So Let's say you reach a temperature of 330 degrees Kelvin as a scientist, and you want to let the local Americans know what that is. So you have 330, subtract the 273, and we get 57 Celsius. Then we plug the 57 Celsius into this formula, multiply by 1.8, and then whatever you get, add 32. That would be 135 degrees Fahrenheit. All right, the other thing that's very interesting to know is wind speed. Wind speed is measured with an anemometer, and there's also a scale called the Beaufort scale. If you have a speed of less than a mile per hour, that's considered calm, and your smoke basically goes up vertically. And then it goes from light air, light breeze, gentle breeze, all the way to a strong breeze, and then finally when it starts to get a little bit, very strong, we call it a gale. So we got a moderate gale, strong gale, a storm, and then finally a hurricane at 73 miles per hour or faster. So that's like over 110 kilometers per hour. And wind can also make you feel colder in the winter, so it can exacerbate cold. And sometimes warm Chinook winds can come over the mountains and melt your snow. So to measure direction, we have a wind vane. In the 9th century, there was a pope named Pope Nicholas. He made it so that all churches would have a wind vane, and they put a rooster on top as part of the wind vane. And then the anemometer is this thing here with the little cups that spin when the wind hits them. Here's the wind chill diagram. So, for example, your risk of getting frostbite in 30 minutes. So, if the wind speed's 50 kilometers per hour and the temperature is around minus 25, minus 30, you're going to get frostbite in about 30 minutes or less. Okay. Here's an example of a Chinook right here. So the warm air from British Columbia would come up over the mountains, cool off, come down, and then be warm and dry when it hit the plains and melt the snow. Okay, here's precipitation. Precipitation is how much liquid or solid water that falls from the sky. Rain is measured with a rain gauge. So for example, this thing right here. So the water falls in and it measures how many milliliters or centimeters or millimeters of rain that you get. And for snow, you just measure with a ruler. Okay. So there's different kinds of precipitation. You got just regular rain, which is large droplets of water. Drizzle, small droplets of water. Freezing rain is when the rain hits the ground and the ground's frozen, so it freezes the rain on contact, making ice. You got sleet, that's when it's already icy, when it's falling out of the sky, so little small pellets of ice. Hail, large pellets of ice that can do damage, like break windshields, hurt people. Snow, small snow crystals. And then you got acid rain, where it's just rain mixed in with acid from usually coal plant pollution. Okay. And so what that'll do after a while is it'll take a nice statue and eventually wear it out, and sometimes that can wreck lakes and rivers as well. Okay. Relative humidity, that's how saturated the air is with moisture. 0% is dry, 50% is half dry and probably comfortable. Usually you want 30 to 50 in your home. And 100% results in dew, frost, fog, and precipitation. So here's like a mist. You can see only things less than 11 kilometers away. Fog, less than 1 kilometer away. Here's a hygrometer for measuring humidity. Here's a psychrometer. You swing that around and it collects water and changes the temperature on a thermometer. You use that to measure the humidity. Here's some dew. That's when the water droplets form when it cools off at night. And here's frost when it cools off at night and it forms ice crystals. Alright, other things that affect visibility besides water vapor in the air are things like sandstorms, smoke from forest fires, dust storms, and haze due to pollution. Alright, atmospheric pressure. This is the force per unit area of the air above the ground pushing down due to gravity. You have to think about it. There's about 100 kilometers of air above you, and all that air is being pulled down by gravity towards the center of the Earth, and that provides air pressure. So here's kind of like a diagram right here. And there's two ways of measuring it. There's a liquid barometer like this, so the air pressure pushes down, and that pushes the liquid up into the middle tube right there. If you do a barometer of water, it needs to be about 10.3 meters tall. But if you use a very dense liquid like mercury, it only has to be 76 centimeters. An aneroid barometer, you just find these little things of metal here, these little, and they're sensitive to changes in pressure. Okay, so they'll turn a needle. These are great. You can tell if there's going to be a change in the weather with the change in pressure. Pressure has a lot of crazy units. One regular atmosphere worth of pressure is 101,300 pascals. 1 bar is 100,000 pascals. 1 atmosphere is also 14.7 pounds per square inch. And car tires are usually around 35 pounds per square inch. And also it's about 76 centimeters or 759.8 millimeters of mercury. So a change in pressure does affect the weather. Really bad storms have very low pressures. For example, Hurricane Wilma is the record for a hurricane in 2005. Only 87% of a normal atmospheric pressure. And the winner for sure is Super Typhoon Tip in 1979, who had only 86% of regular air pressure. So definitely feel that. Okay, so besides that, we also have radar and weather balloons. Doppler radar, like this right here, provide us with air motion, so we can see what the wind's doing. You can also detect tornadoes with this. We have weather balloons, which go up in the sky and collect information for us. For example, this one's up to almost 106,000 feet. There's one there. And you can detect swirling motion like tornadoes, and you get your tornado warnings on the radio. Of course, our best instruments these days are satellites, weather satellites, mixed with mathematical models and computers. So the first weather satellite was launched in 1960, and information technology and meteorology has improved since then. So forecasting is improved by about 1 day per decade. So for example, in 2020, a 4-day forecast is as accurate as a 2-day forecast from the year 2000. So 2 decades and you get 2 days more accuracy. It's pretty cool. Satellites can provide us with visual observations of what's going on, also infrared, and of course you can stick radars on them as well, and lasers. Alright, and I'll stop here and we'll do part 2 after this.